Good day. Today, I will be presenting Qapla Policy Compliance for Database-backed Systems, written by Aishta Melta, Katura Avi, and Ellington T. Exlam. My name is Ayobami Olatunji, a computer science student from Western Illinois University. The outline, the introduction, we've talked about why we want to do Qapla, and also the Qapla itself, the system, what the system entails, how the system works, and what you should be expecting from our system. The Qapla framework, which is the policy framework for the system. Also, I'll be talking about the design. The design is the architecture and the working model or the procedure at which Qapla is designed. We also have the working principle to discuss today, then the limitation and the challenges that we faced, that was faced when Qapla was actually made. We also have the future work, which is what is to be done, what we discovered from the design of Qapla, the future work for future purpose. Also, we have the conclusion part, which is the summary and the closing part of the paper. Introduction. Confidential information protection from normal data in the system. In the present world, we have so many information available in digital form, so they need to be protected because most of those information can be used to know our status in the society, know what we have in our accounts, have every details about us. So these are confidential information. They are like the SSN, the social security number, which is the SSN. Phone number sometimes can be classified as confidential information, date of birth, and the rest of things like that. So all this information needs to be protected compared to normal data, which are general, in a way to ensure that the database-backed system provide that confidentiality. They use or utilize many policies in order for us to do that. We have the user-specific, which we have an instance where ordinary employee may query their own personal information. In user-specific, for instance, like myself, I can query my name in the database and get a result. Can get a result of my name, probably my age, and some basic information about myself. This can also be like another way for somebody to get a little bit of information that has been submitted to the system. But in user-specific, they can only get information that is being particular to that particular user. So I can get information for myself, Ayobami, but I cannot get information for any other person in the particular system. We also have another method that is being used to provide this confidentiality is role-based. So in role-based, a member of a particular group can be able to get some certain information. Say, for instance, the instructor for CS512 can be able to get information about all the students available if queried the database. But I cannot be able to get such information if it is tagged confidential. I can only be able to get my own name as a student of the class in confidential information under the user specific. But in role specific, the instructor has an higher level of access and will be able to get such information. I can be able to see my grade, but I cannot see the grade of the whole class. So those are the ways the user specific can be used in providing this data. So there are some columns that can be queried, and there are some that you cannot query. So we also have time specific. There's some information that you can get only based on the time. When the time has lapsed, you cannot be able to get that particular information. For instance, maybe there's a course for spring. You can only query such course for spring, but when the spring semester has ended, you won't be able to query that particular course again or get any information from that particular course again. So those are time specific. There are some things that cannot be queried from 12 a.m. to 3 a.m., depending on the policy that is being set. But those are some of the methods that are being utilized in providing security for confidential information. The method of protecting confidential information are implemented and enforced is by adding compliance check to the application. So in order for those things that we said in the previous slide here to be done, there's always a compliance rules and policy that are being put onto it. In other words, the system must be able to differentiate a user from an instructor, just like the example of where I can be able to see my own grade, but I cannot see the grade of the rest of the class, but the instructor can be able to see that particular grade for the rest of the class. So the system has been configured in a way with policy to allow me. So the system must be able to like identify who the instructor is and who is not the instructor in order to display certain information. So this is being enforced by adding compliance check to the system. Unfortunately, the approach is very, very cumbersome. It is very, very problematic in nature. When managing such, you need to continue setting the rules for each user. When there's a new instructor, you need to upgrade that. When student leaves, you need to like remove the system. So you need to remove the students. So the approach is actually kind of cumbersome. So when setting those rules and managing them, error is possible, as most of those are not done automatically. They are being done manually and by human, which can lead to error. Like we have always been saying, that human is the weakest link in every security configuration, so, or in every system. So error can happen in this case, and error like that can also like be kind of go beyond what we think it might be. A simple mistake in number, letter, or column in that particular case can grant access to somebody else who is not meant to have such access. Imagine like an error in configuration or in adding a compliance check to the system allows students to be able to change their grade or upgrade their grade. This is possible with just a comma, with just a number or a letter in the system. Or it can also even deny people to have access to what they are meant to have access to. An error also can deny the instructor from having access to all the students, like information or grading system or whatever it is. So compliance rules might also be missed because the way at which policies are derived are somehow broad and large, coupled with the fact that the environment of implementing those policies are always enterprise in nature. Like when you are incorporating policy, the environment is always large and enterprise in nature because of the fact that you are dealing with organizations with thousands of database, thousands of servers, thousands of information, or millions, as the case may be. So it is always very, very like chance of missing some compliance check is possible, which is actually another security problem. Another part is it is not flexible. And it is not flexible in the sense that when you're working in an enterprise environment, like I said, you work with various databases. So the policy of this nature do not always like work with all database management system available. You might have rules or compliance policy check that works for Oracle, say might not be applicable to PostgreSQL or something like that. And with enterprise environments, there's always the chance of multiple database management system across various departments. So these are the problem with the present system. Now, the Qapla, the system itself. The Qapla system is designed to eliminate the problem that we listed here. The problem of cumbersome, error-prone, not appropriate, missing some checks, and the non-flexibility of it. So the new Qapla system is designed to eliminate that. The new Qapla system, it can express a rich class of policy. The new system provides solution in the sense that in the rich policy, it includes standard fine-grained row, the row, column, and cell level policy. Also, complex policy that limit data linking or allow aggregation. This policy specification must be associated with database schema and independent of application. So, which is also another way when we are talking about the system whereby you have a multiple environment and an enterprise environment where you have configured a policy for probably for Oracle. You don't need to do the same again when you want to do the PostgreSQL. They should be able to like find a way for them to like interact together. It should also be simple and intuitive in the sense that it must be easily to configure, to troubleshoot, and to manage by the administrator. Anything out of that can lead to error. So the Qapla system is designed to be such system that is very, very simple in troubleshooting, managing, configuring, and the rest of things like that. The system also does not depend on specific support for the database management system. Like I said, it is transparent to all or to various database management systems. Let me put it that way. It is very, very transparent in this regard. So the system offers adequate protection for data confidentiality in the face of application block. The framework, the policy framework. Qapla allows a policy compliance team to achieve a set of policy with a database schema. The policy specifies the data confidentiality requirement that takes into account the database schema, content, and authenticated user, time, and operation like join, aggregation, and UDFS. Every Qapla policies apply to a class of query and specify how the query must be retrieved, must be restricted to be compliant. So for example, in this case, like I said, there are so many ways in which data can be queried. And, we are talking about confidential information. We do not want somebody without access to be able to have access to the information that they are not meant to have access to. So example of this is the resource database for human resources, the database for human resources of a company, which is called ACME. So the data has 3 tables, which is the employee. So the employee has employee ID, the name, the address, age, gender, and department. Also, the payroll table has employee ID and the salary linked to it. The benefit also has the employee ID and the health plan in this case. So the first table, it maps the employee to the ID with the name, to their house address, to their age, to their gender, and to the department at which they are working. Also, the payroll matches the maps the employee ID to the salary, while the third table matches the health plan at which the employee is using to the employee's ID. So with this, each employee can have their own information mapped based on this particular table. So this is the policy at which this framework works. So some sort of the policy I explained, there are various policies that is used. We have up to like 5 of them. The simplest of them is the single column policy. The single column policy, the single column policy kind of protects a single database column by specifying which role of the column that can be accessed by each user and when. It has this form like the where clause of which you want to access in the role. So for the system to know the column and the role at which it must return. So the particular example shows like the name, the age, the head department, so which is the name of the company that we discussed previously. So this is actually like what is being queried from here. So the SQL fragment exists here is specifying a condition that holds only if the authenticated user is available on the system. So what this is saying is only if you are a registered member of this company, that is when you can be able to do this. That is when you can be able to access this. If you are not registered, then you won't be able to proceed forward in you querying this particular database for this. So it's specifying a condition that must hold in this regard. So this is the simple way of it, is selecting from employee, where employee ID is equals to user. So this is what this is saying. So this is actually like the least or the easiest protection or the policy framework that is available under Qapla. So we have the link policy. So the link policy is kind of a policy that links more than that links 2 or more things together. So it is being the general format of it is here, which is the column 1, column 2, column 3 to column n, which is to infinity or to certain number. So when a query reads 2 or more columns, the applicable policy may be more restrictive than the individual policy of all the column read, because additional information can be exposed by linking columns to each other. So you need to be careful when you are linking policy in order not to make a mistake of linking what is not meant to be applicable or to be available to a certain user when you are linking. In this example, we are trying to link the name and the age together. So this year, the policy of the column name and age allow like any employee to read this information individually. So just like we have in the previous example here, just like we have in the previous example of simple single column policy. So it allows the individual or the employee to read this column individually. However, not every employee should be able to read column name and age together, because that will reveal so many information about the age and the particular employee, which is actually like kind of being regarded as private. The right policy is that in this case, if you want to see the two together, only the HR and the employee themselves or him or herself should be able to read that particular information together at the same time. But a different entity should not be able to like see that particular information together, except the HR. So this is what we have here in this example. We have the employee to the employee ID, cost to user, or exists, which we have said previously, like it must be in the system, to select from employee where the employee ID is equals to user, which is available in the system. And that person is a member of the department from HR. So if you are not from the HR department, you should not be able to see this policy together. So this is where care must be taken when you are linking two things together. You must be careful not to allow those who are not meant to have access to that to have such access. The Qapla policy framework continues here with the transformation policy. And transformation policy in this case is being like grouped in a way where we have like the column, just like we have in the link, column 1 to column n. But in this case, we have the transformation number also to be included, T1, T2, T3 to Tn as the filter condition. So the transformation policy itself is an application that often like allow functions to transform to column to hide sensitive information. Like in transformation policy, the policy might be more kind of permissive than the column itself. So Qapla directly supports such transformation. So the filter condition are of the same form as we have in the link policy. The policy applies to any query that access subset of the column, like column 1, 2, 3 to column n, but only after the transformation has been done before this can happen. So that is why we have the T1 to Tn in this case. So for the example we have here, let's assume like our imaginary company now wants to run like a shuttle system where they kind of like have a fixed stop. But since this system, since this system is not door-to-door system, it is like to the nearest bus stop, we need to be careful not to allow the logistics department that is going to be in charge of this particular program to have access to employees' main address, like their house address. They should be able to have access to like the nearest bus stop available for them, but they should not be able to have access to the direct house information. So in this case, that is why we have the transformation policy in place. So in order to provide this service, member of this logistic department, they are to know the nearest neighborhood, but we don't want them to know the precise home location. So to enforce this, we create something called the transformation policy. So where we have the name, the address, and we transform that to the neighborhood. So this is what is happening here. This is the name, this is the address. Then we transform that to the neighborhood. So when we transform that to the neighborhood, we have the employee ID is equals to user, which is to show that it is in the system. We select from the employee, and we have the department to be equals to HR or department to be equals to logistics. Like we said, HR have like enough access to like see the name and the address of individuals together, which is not available to individuals like beyond their own personal address. But HR like have the opportunity of seeing for everybody. So we are saying that where department is equals to HR, or in this case, where department is equals to logistics. So we are giving the power that we have for HR kind of to logistics, but we are saying that it should only be for name and address. In the HR case, we have name, address, age, and the rest of things. So what we are trying to protect here is the fact that the logistic department does not need the aid of an individual to give such person access to the bus service, to the neighboring bus stop. They only need the name and the age in this case. So this is the transformation policy of our system. We have the aggregation policy. Many applications declassify aggregation statistics on otherwise private column. So in Qapla, it provides the aggregation policy. So the aggregation policy actually have like two sets of columns, the LS and the JS column, which is joint or group data. So both of them are always like aggregated together. The JS is being referred to as the joint set, while the LS is being referred to as the link set. So the example that we have been using with our imaginary complaint also still applies here. So let's suppose that there is a group called the Workers' Council. Let's assume that they are the one that probably compute the salary statistics to ensure like everybody is getting paid what they are meant to getting paid, probably based on age, based on their age range, or based on certain criteria. So instead of us to provide the WOC the access to the full data, they do not need those full data to like do their work. They basically and only need information about the employee, like the employee ID and the employee name, then linked together with the age range. Since the salary upgrade is being determined by age range, say from 10 to 20, 20 to 30, 30 to 40, as the case may be. So in this case, we want to like link this age range to the WOC, not like the age itself directly. So in this case, we want to like join the payroll information, then link it to the age range for the WOC to be able to access that particular information. So here is what we are doing here. Like we are saying that we want to join the payroll, the ID, the payroll table with the employee ID and the employee with the employee ID. So we want to link that with the age range. So in this case, you are saying that age, then we are converting the age to range. So in the sense that if you are between 10 to 20, then you should be in the same age range. If you are between 20 to 30, you should be within the same age range. Then also the average salary for that particular range. And we are saying that you should select from employee, where employee ID is equals to users, know that you are a user on the system. And also if department is equals to HR, which have access to all this information, or department is equals to WOC, which is the new department that we are creating for the salary system. So the policy allows the WOC to run any query that joins the payroll table with the employee, and then they only have access to like the age range and not the age itself, and also the average salary in that particular way. So that is how that is being protected. What we are trying to do here is the HR department and the WOC. The HR department has access to all the information individuals age, but we do not want that to be linked together easily or at all by WOC. Instead, we want them to only have access to like the range that is available in that regard. So that is what that is doing. We have the relation between policy classes, which is like the fifth policy framework that we have. So this basically is telling us that there is a way, like the four policies that we have been able to discuss, which is the single policy, we have the link policy, we have the transformation policy, and we have the aggregation policy that we just discussed. There is a way that they are increasing more general. Single column policy are instance of link policy, and the set of link column is actually kind of like transformation policy, and you know, like it is just like relational policy between all of them. So that is what the relation policy explains. There's a way we continue linking them up from only one user having access with a single column to their particular information, to the other one which is linked, which allowed the HR department alone or some certain department to be able to like have linked information together for more than the individual. Then we have the transformation policy, which allow like temporary departments like logistics to be able to like have access to information in order for them to do their job and not necessarily have information, access to all the data available about user. Same thing with aggregation policy, where we are linking where we are joining and linking together the payroll information with the age range instead of joining together with age alone. So that is relational policy. And we have one more policy, which is the policy inference heuristic. So this is to reduce the burden on specifying policies. So this policy like provide the 3 safe heuristics. So we have like the first one, which is automatically applied to any subset of column. So a link policy of a subset of column also automatically applies to any subset of those columns, since reading a subset only reveals less information than reading the whole set. So a link policy in the same case, in this case, like automatically applies like to any subset. So if I'm able to access name, age, and my salary, I should be able to access any subset of that information. Like the subset is actually like a minimal information to the whole set itself. So that is the first one. The second one is talking about use link policy in the absence of other policy. So if a query uses column transformation or aggregation, but a specific applicable transformation or aggregation policy does not exist in a case where that does not like exist. So Qapla can use the link policy of the set of columns that occur in the query if one of them exists. So just like what you have done with transformation and what you have done with aggregation. In case where we do not have opportunity to do that, link policy can also work in the absence of that. And the third one here is an explicit link policy can be designed. So in place of writing an explicit link policy on a set of columns, the designer can actually like instruct the Qapla to automatically construct a link policy for a set of columns by combining those individual policy or individual column in the set. So instead of like you needing to like have the transformation and the aggregation, there is a way you can explicitly link policy to a set of columns in order for you to still be able to do the same thing that you would have done using the transformation and the aggregation policy. So this is our design. This is the Qapla design. So the Qapla design architecture is grouped into 2 distinct sections. We have the untrusted part and the trusted part. So in the trusted part, we have the Qapla metadata table, we have the application data table, we have the database engine, we have the relating query, we have the policies, we have the policies compliance results, we have the Qapla reference monitor. Then in the untrusted aspect, we have the application and we have the authenticated credentials. So in this case, the user is trying to like come into the system, it has to be authenticated, just like what you have been saying, that you must be a user in order for you to be able to like be in the system. So, or to query or to do anything in the system. So this is the application you are trying to enter the system with, which it can be anything, which is untrusted kind of. Then when you like try to like authenticated already, then you are trying to query the system. There's something we have here, which is Qapla reference monitor. And in the case where if your information is like, if the query method you're trying to use is policy compliance, it just goes straight to the metadata, pick the information, then go back to the user. But if it is not compliant, the Qapla reference monitor has the power to rewrite such query, which is the relating query here, then before enter the trusted table here and be able to like return to you. So the Qapla is the policy compliance middleware for database-backed system, which satisfies the all the things we have been discussing with moderate overhead. So the Qapla is actually like more specified, like or more designed in like SQL like language. So like it's a function of the database schema, and it is stored just like the way SQL is. So SQL is actually a natural choice for Qapla language policy, since it is like syntax is widely understood by almost everybody in the database industry or in the IT industry generally. So for the policy enforcement, Qapla integrates a reference monitor, which is here the Qapla reference monitor, the monitor with a generic database adapter, so which intercepts all application queries. So when you are trying to query the system, if it is written in the way the Qapla understands, fine, it goes straight. If it is written in a way that is not being understood by Qapla, it's actually like rewrite that query. So all application query are going to be intercepted, then look up the applicable policy for that, and the written query to ensure that it complies with the system. So the enforcement is transparent to application query that are already application compliant or policy compliant rather. So the application has to be changed only when it is not in compliance with the system. But when it is in compliance, nothing is going to be done. It's just going to go into the system, then pick the results and send it back to the user. But only when it is not in the compliance system. So this is the design of the Qapla system. So the working principle. So Qapla itself is designed to prevent data leak due to application bugs that result in non-compliance query to the database. So the Qapla intercepts all the query to the database in a reference monitor and rewrites the query to make them policy compliance. So the reference monitor runs the same address space as the application. So the reference monitor like monitor the query as they are coming in and be sure that the information is actually like very like accurate or in compliance. So any application level bugs, of vulnerabilities that can circumvent this monitor to access the database or steal information from the reference are always like rewritten to comply with what the database can do. So the Qapla reference monitor, the database adapter is enabling the database system. So the database curator or compliance team is assumed to have installed the correct policy. So any information referenced by policy is assumed to be correctly stored in the database under the assumption that the Qapla guarantees that only policy compliance query are returned to the application. So yeah, what this here is saying is just like basically the database, the end part of the design here, the metadata table and the application data table, assume that everything that can get out of this reference monitor has been properly configured, has been checked and tested, and it is actually like valid, and there is no error or there is no problem in returning that particular information. So the policy enforcement on a query consists of two steps. One is identifying the set of policy that applies to the query. So Qapla treats every policy as an aggregation policy of the form of join set and link set. So the filter condition where join set and link set are respectively like the set of columns that may be used to only join two or more tables, and the set of columns that may be projected are grouped by this. So this is like the most general form of all the policy, as you can see on the left-hand side. The all single column link and transition policy can be expressed in this form. So Qapla like passes every application query to extract the corresponding set of join set and link set of column that are only used to join sets. So in this case, the input here is query Q policy is equals to JS and LS, which is the filter condition. Output is true if policy applies to Q, then false otherwise. So this is what this is explaining, saying that it is true if policy applies to Q, then else it is false. So this is actually like being like demonstrated here using the J and LS. So for each column in LS, if it is not in LS, then it will return false. And for each transformation, C is equals to T in LS. If this is not equals to ls and is not equal to ls, then it is going to be false. So it must be true before it can return true in that particular case. So the second policy is relating the query to filter out the tuple disallowed by all application policy. So when you are trying to access the system, like I've explained in Qapla, is that when the query is not in compliance, the reference monitor always like rewriting the query. So in simple and common case where only one policy applicable to the query, the policy rewriting algorithm replace each reference to a table in the query with a subquery that generates a list of what is in compliance with the filter condition of the column that is to be accessed. So where the list or the filter condition of the table provide the policy, the overall effect of this is that the application query is executed over joins or policy compliance subtable or one or more database table, where the subtable have been created using the filter condition of the applicable policy. So like in this context, like the company we have been referencing, so assuming like some link policy exists for this particular column. So this is like the general link set. Like what I explained, that when there is no transformation or aggregation, you can be able to still like use link state to do that. So what this is saying is the query is going to be different. So the subquery is going to be in the form of select asterisk from table, select all from table, where the list of, then you have to like specify those conditions of what you want the order to see. So we have the name, age, health plan, employee ID, the benefits, and that is specific that where clause FE and FB for filtering the table. So employee and benefit respectively. So these are the two tables that we have, the employee and the benefit. So in this case, consider the following query. You are trying to select name, age, health plan from employee join benefit table. This query will be written to be. So it's just like what you're trying to do here is you are trying to like select information from two tables with linked policy, which can actually like be done without written it in this particular way. And it can also be done with transformation policy or with aggregation policy. So the rewritten query is done using this particular method and in this particular regards. The working principle of the system continues. There are 3 ways to optimize the Qapla system for effectiveness to reduce the overhead of policy. This is like on the aspect of us talking about the optimization part of the policy, because the policy must like be well optimized. The system must be well optimized in order for us to have the outcome that we envisage in this particular system. So the query template cache, which is a query template that is query with all the constant value replaced with placeholder value. So the this particular monitor implements a query template cache to amortize the overhead of passing and rewritten query with the same structure. So the template map every template to their rewritten form. So when a query is received, the Qapla convert the query to a template and check if the query template with the same hash is already cached in the system. So if there is it's fine. So for instance, like there is no need to like query that again if it is already available. Immediately the Qapla receives that, it actually like check and see if it has already been cached, like the same hash value has already been cached in the system. So it just bind if there is it. And in a case where there is no it, so when there's no it for a miss, it passes that and relating the query with the applicable policy, and then put the result this time in a cached file or in a cached system. So when the same query is being run again, it just check for the hashes. If it is the same, then it's return it, have it and return that. So that is the query template cache. Then we have the partial evaluation, which is executing the query efficiently, which depends on the ability of the database management to generate an efficient execution plan for the rewritten query. So What this is saying is the Qapla reference monitor often generate complex rewritten query containing several like subqueries, nested subqueries, which needs to access like one or more table with so many large filter. In order to like reduce such complexity of the rewritten query, Qapla can like pre-evaluate part of the rewritten query that do not depend on the database value, like like where you want to like or check the identity of something or who is trying to like access something. So before posting the query to the database, this can like significantly like reduce the time and the time at which something is returned, because it has already like in one way or the other like pre-evaluate that part. So any pre-evaluate connected by hand to a pre-evaluated predict that is false can also be replaced by a single false before the query is sent to the database. Similarly, any predicate connected by all to a evaluated predicate like that is true can also be replaced by a single true. So what this is saying is if it is predicated by an and, it can reduce false like for that, than if it is connected by an or, can reduce true. And the last one is the materialized view, which is to offset the cost of policy check during any query evaluation. Qapla can create a materialized view. In a group materialized view, every cell inaccessible to the group is replaced with a special value that is not a legal value for that particular underlying table. So one for each group of users with similar permission by applying the applicable policy to the table offline. So at the runtime, every application query is run against the materialized view appropriate for the authenticated user. Like the query is written by Qapla to disregard any record that contains the special value in the field that is used in the query. Say, for instance, like what materialized view is trying to do is every cell that is unavailable to you that you don't have permission to check will be replaced by a special value. So that is not the legal value of the system. Say, for instance, you're trying to like see age, and you're not allowed to see that particular cell. So it is going to be replaced by like an imaginary value, like not an imaginary value, but illegal value, XXX, for instance, 111, for instance, jargon's value in short to say. So the Qapla challenges and limitations, here are some of the limitations and the challenges of the new Qapla system. The isolation of the reference monitor is actually one. Presently, we assume the same address space with the reference monitor cannot circumvent the reference monitor or steal its authentication credential. So such absorption might be forced at the long run. So we can instead isolate the reference monitor in a different processor, in a different processes, or use the co-location system with database server. The user authentication, Qapla current design requires the application to specify like which user behavior is it acting on. Like you have to like authenticate before you have access. So an application may like specify the wrong user to like Qapla due to a bug, which is going to break the Qapla policy enforcement. So in a case, this policy can be addressed by having the user authentication to the reference monitor itself instead to the application. So the reference monitor policy can be able to know which user is directly connected to it instead to the application itself. So also protection against offline linking attack, which is saying that Qapla does not protect against like offline linking attack that can span multiple queries in a case where like due to information contained in data itself, like name may have high correlation with nationality of users. For example, like Ayobami is actually like much more like have nationality like in quote like most people from Nigeria has the name Ayobami because it's a local name and stuff like that. And there's a way to like link that together. So which may reveal individual records. So like tools to check such condition on policy can also be designed or can be designed easily So the final one here is support logging. So support for logging is actually a natural way when we can modify the Qapla reference to detect the log non-compliant query. So when Qapla is trying to rewrite query, it should be storing the query sent initially in order for the system to update more and be able to understand such queries. So if there's a particular query that is being sent to the Qapla system multiple times, say 50, 100 times in a day, or that has the highest number of requests, and it is being rewritten, Qapla should be able to have a support logging system that should be able to incorporate that into the system. So when that is being sent, there won't be need for any rewriting as it has been incorporated into the system of Qapla. Future research avenue. So there are always room for improvement. The study opened a opportunity for research in the aspect of practical implication of the fine-grained access policy. It's also open another way of effectiveness of Qapla, like we have discussed. There are some limitations, that can be worked on in order to have much more effectiveness. Also, the native database management access control optimization. We create Qapla to be accessible to multiple database with the same policy, but then there's always a way to look into how more database can be accessed, like control mechanism, which is actually an aspect that can be good for future investigation into optimizing and enhancing controls on how the policies are being implemented across board. Finally, on the area that is open to future research is the broader implication of Qapla. We have been able to highlight the positive aspect of it, majorly how it helps in solving the problem of the pre-existing system. There is room for us to look into how a new system can also come and be able to provide solution to the problems that comes with Qapla on its own. And maybe there is any break in the system, how it can be fixed, and to make the system more better. So there's always a broader view of things in that particular aspect. In conclusion, the system presented the evaluated Qapla, which ensure compliance with confidentiality policy in database-backed system. The architecture provides an avenue for the policy rewriting and solve the problem associated with the pre-existing system approach, which is cumbersome, error-prone, and non-appropriate, misses some checks for compliance. Finally, it provides independent architecture that can operate easily with any sort of database with little to no issue at all. Thank you for your attention. Time.